Hello everyone, my name is Likhit Tanishq, and in this presentation I'm going to present to you my project, How does water salinity affect the plant's growth? So, water salinity, my project is about water. The elixir of life serves as the lifeblood of our planet, nurturing the growth of plants and sustaining ecosystems. However, the quality of water, particularly its salinity, can profoundly impact plant growth, presenting a significant challenge for agriculture productivity and food security worldwide. In this exploration, we should delve into the relationship between water, salinity, and plant growth, aiming to shed light on this pressing issue that affects farmers, communities, and ecosystems alike. So, the genesis of our inquiry lies in a fundamental question: how does water salinity affect plants' growth? Which leads to my hypothesis. To This question serves as the cornerstone of our investigation, propelling us to delve deeper into the complex interplay between salt levels in water and plant physiology. Drawing upon existing research and observations, I formulated a hypothesis that higher salinity levels in water would hinder plant growth, while lower salinity levels would promote healthier growth characteristics. To test my hypothesis to the level, first of all, let's explain what is water salinity. So, water salinity refers to the amount of salt in water. So, imagine if you tasted seawater, it would taste salty. That saltiness comes from dissolved salt in the water, like table salt, but in smaller amounts. For example, salinity is measured in parts per thousand, which tells us how much salt is in the water. So I believe you have a basic understanding of salinity. So now, to test our hypothesis to the theory, I designed a meticulously crafted experiment. So the first step of that experiment would be to select a plant suitable for the experiment, like tomato or Pisum sativum. But we need to take a common but simple species of plant to ensure easy and cooperable results. So dividing the plant into high salinity, low salinity, and moderate salinity, and regular salinity, and each of them receiving normal water but with different levels of salinity. So we would regularly measure the growth with a ruler or measuring tape and check the leaf count of the plant with the ruler and all the materials I used. So next would be observing any visual document symptoms, the plant or any stress, recording water usage, measure and record the same usage of water in plants, and checking the weather condition, make sure it maintains the same consistency. So these are the procedures. And next we have our data analysis. Excuse me. Our comprehensive data analysis reveals that compelling insights into the relationship between water and plant growth through meticulous observation measurement. It took me 4 weeks to put down these results. And so the data collection. I collected the data on plant growth metrics, which included height and level count across different salinity levels over the course of our experiment, and the graphical representation utilizing the line graphs and using Python to put my data and create a Python to make Python create a graph, and trend identification to identify if it's linear regression or not, and correlation, which helps us find if our findings aligned with our initial hypothesis, which did, and analysis, which when I conducted statistical analysis to further validate my research results and ensure that they're correct. And these analyses confirmed that my trends were safe. So on to the next one, which is this is the graph which Python generated for me when I gave them the data table of 4 weeks. So I have average height in centimeters and the number of week and the salinity level here, which shows that which this graph completely matches my hypothesis. As the levels increase, the average height decreases and everything normally declines. And let's check the other graph. And the other graph is a bar graph. So you could see your weak salinity group and how the leaf count has been changing a lot, tremendously a lot. Or, yeah, mostly, yeah. So therefore, the conclusion of this project is in wrapping up this research project, I've uncovered important insights into a global issue, water salinity. So my exploration began that understanding water salinity is a risking concern worldwide goes often unnoticed. Excess salt in water could also act like this is all the introduction to water salinity and the hypothesis guiding my experiments. So basically, the graph showed plants watered with lower salt levels exhibited healthier growth. And my engineering goals proposed more innovative solutions like creating salt tolerant plant varieties through genetic manipulation. The experiment also procedures involved selecting a common plant species and dividing them into groups based on the salinity levels, and also addressing the risks and safety concerns. So most importantly, I wanted to show the results, which I've got. And here you can see the salinity level 1, 2, 3, 1, 2, 3, and the plant height in centimeters with the leaf count over here. So this all perfectly matched with my hypothesis. This perfectly all matched with my hypothesis. Also, moreover, my experiment underscores the urgent need to address water salinity, and by deepening this understanding between water salinity and plant, I paved the way for transformative solutions that promise to revolutionize agriculture and secure food security. And last but not least, my bibliography. I have reputable sources like Smith's Plant Growth and Soil Salinity websites. These were to increase my understanding of the impact of salinity on plants. Finally, my real life use cases on how does water salinity affect the plant's growth. So first, agricultural practices. So first, farmers can apply our findings to optimize crop production in regions affected by water salinity by selecting salt-tolerant plant varieties and implementing irrigation strategies. Farmers can mitigate the negative effects of salinity on crop yields and ensure sustainable practices. So next we have environmental remediation. So what that does is basically provides us insight on saline soil and water resource. Then we have urban landscaping, which architects and urban planners can incorporate salt-tolerant plant species into an urban green space and garden. That means um, it reduces maintenance costs and water usage. And hydroponics in aquaculture and hydroponic system where water critical is critical for plant and fish health. Our findings can guide the management of salinity levels. The hydroponic growers can monitor and adjust water salinity to optimize growth conditions and maximum yields with this experiment. So also water management policies and police policymakers and government agencies can use this, and educational, this could be used in schools in STEAM fields and environmental conversation. Last but not least, this is my quad board used to present in the UC Science Fair. It explains everything, the procedure, the hypothesis, the statement, the data analysis, and the interpretation. Last but not least, in conclusion, the Water Salinity and Plant Growth Project serves as a testament to the power and discovery in pressing challenges confronting humanity. Through rigorous experimentation and analysis, I have found the profound impacts of water salinity on plant growth, laying the groundwork for innovative solutions that hold the potential to revolutionize agriculture. As I look ahead, let us remain committed to the pursuit of knowledge and the advancement of sustainable practice that harmonizes human activity with the thrive of the natural world. This is my project, Water Salinity. Thank you.